Hello students, today we are going to see 4-bit magnitude comparator. And for this magnitude comparator, we are going to write the RTL code as well as test bench. Let us enter into the session. Before entering into the session, please subscribe my channel VLSI Web Dr. Leena. Yeah, now what is magnitude comparator? Magnitude comparator is a digital combinational circuit used to compare two binary numbers and determine their relative magnitude. It tells whether A is greater than B or A is equal to B or A is less than B. The circuit produces three outputs representing these three conditions. So, in this magnitude comparator, it will be comparing whether A is greater than B, A is equal to B or A is less than B. Now let's enter into the RTL coding. First, the module, the keyword is given and then the name of the module is given and we are opening the bracket. So we are giving the input, that is it is 4-bit data and bits are numbered from 0, 1, 2, 3. This A is the first input number to compare. And then we are giving the next input. This is also 4-bit input. B is the second number to compare with A. And next we are giving the output, that is greater than. This output signal becomes 1 if A is greater than B. In this, reg is used because the value is assigned inside an always block. We must declare it as reg. And next, output we are giving as equal. This output becomes 1 when A is equal to B. Next, output as less. Here the output becomes 1 when A is less than B. After assigning all inputs and outputs, now we are ending the port declaration list. After assigning the inputs and outputs, now we are going into the operation. This always block means the code inside runs whenever inputs change, and this means trigger when any input changes. In this design, inputs are A and B. So, whenever A or B changes, the comparator recalculates the output. This is a combinational logic. First, if A is greater than B, begin. That is, this checks whether A is greater than B. And if condition is true, it gives greater than is equal to 1, equal to is equal to 0, and less than is equal to 0. Only one output should be 1. And for this condition, greater than is equal to 1. It ends the operation, and else if A equal to begin. That is, if the condition fails, it checks A equal to B. And if A is equal to B, the greater than will be 0, equal to output will be 1, and less than will be 0. And it ends the operation. Next, if both previous conditions are false, the only possibility is A less than B. So, if A is less than B, then the greater than will be 0 and equal to will be 0 and less than output will be 1. Next, it ends the else block, and then it ends the always block, and finally it ends the module. So this is the magnitude comparator RTL code. Yeah, now we are going to write test bench for the 4-bit magnitude comparator. That is, we are giving the module and we are giving the name of the test bench. After giving the name of the test bench, we need to give the inputs and outputs using reg and wires. So I am giving the first input using reg and the next input using reg, and then the outputs greater than using the wire and equal to using the wire, and the output less equal to wire. Once after giving the inputs and outputs using wire and reg, obviously the next step we need to do is we need to instantiate the module inside the test bench. So we are instantiating the comparator. Look at this. First we are giving the name which we have given in the module, and then we are using unit under test and we are opening the bracket. Here we are connecting the test bench input with the module input, and next test bench input with the module input, and then test bench output is connected to the module outputs. All the other outputs are connected and we are closing the instantiation. Once after closing the instantiation, we need to give the test cases. So we are initially beginning it, and the case 1 is A is greater than B. Here, look at this. We have given A is equal to 4-bit decimal number 10. And then for the B, we have given B is equal to 4-bit decimal number 5. That is A is equal to 10 and B is equal to 5. Here A is greater than 5. So the expected output is greater than will be 1. And we will be first testing this case, and it waits for 10 time units and then execute the next case. And look at this. The second case is A less than B. And we are giving A is equal to 4-bit. This is decimal and it is 3. So the A value is 3. And here the B value given is 7. So here, look at this. A is less than B. That is 3 is less than 7. So obviously less than is going to be 1. After doing this case, it waits for 10 time units and it executes the next one. So the case 3 is A is equal to B. So look at here, when A is 4, that is 4-bit decimal 8, and B is also 4-bit decimal 8. So the value of A is also 8 and B is also 8. Both are equal, and when it is equal, the expected output as the equal to will be 1. So in this case, it performs the operation, and after 10 time units, now we are giving boundary values as case 4. Look at this. First we are giving the value for A as 0 and value for B as 15, and we are checking the case. After checking it, it will take 10 time units and performs the next case checking. So in the next case, A is given as 15 and B is given as 0. So it checks it, and after 10 time units, it will stop the simulation, and then it ends it and ends the module. So this is the 4-bit magnitude comparator test bench. So students, in this what we have done is, first we have given the inputs and output using reg and wires, and then we have instantiated it, and we have checked 4 cases. The first case when A is greater than B, and next case A is less than B, and then A is equal to B, and then we have tested it for boundary values, and we have ended the operation. So now let's see how the output table is going to be. Yeah, students, look at this. This is the output table of our RTL code and test bench. First, the times which we have framed, that is after 10 time units we have framed that, and it is given here. And we are taking the first 4-bit input A, and next 4-bit input B, and then whether it is greater than or equal to or less than, and what is the condition of it. So first you see here we have given the value of 10 for the input A and value 5 for the input B. So here A is greater than B. So look at here, greater than will be high and all others will be 0, and the condition is A greater than B. Next you look at this, the A is 3 and B is 7. Here we know that A is less than B, so the greater than is 0, equal to 0, and less than is 1, A is less than B. And in the next case, you see A is 8 and B is 8, both are equal. So greater than is 0, equal to is 1, and less than is 0. A is equal to B. And you see the next boundary cases, A is 0 and B is 15. This means A is less than B. So greater than is 0, equal to 0, and the output is less than. So A less than B. And in the next case, that is A is 15, B is 0. So here A is greater than B. So the greater than output is 1 and equal to 0, less than is 0, and the condition is A is greater than B. So this is the output table of 4-bit magnitude comparator. So students, after this we'll be moving to the next level coding in sequential and FSM. Using those things we will be writing different codes, and if you want to learn more codings, please subscribe my channel VLSI with Dr. Leena.